Quadratic inequalities. So the first part of this is we're going to talk about how to graph a two-variable quadratic inequality. So the first step is to graph the parabola and making it either solid or dashed depending on the inequality symbol. So there's a few steps we need to take to graph this parabola. So the first thing we need to do is we need to find the vertex. Since this is in standard form, we find the vertex by finding the axis of symmetry and then plugging this value back into the inequality to figure out the value of y. So to figure out x, we're going to take negative b, so negative of negative 2, all over 2 times a, which is a negative 1. And simplify. So we get a positive 2 over negative 2, which equals to negative 1. Now that we have the x value of the vertex, we need to find the y value as well. So we're going to take this x value and substitute it back into the inequality. So we have y less than negative of x is negative 1 squared minus 2 times negative 1 minus 1. Simplify this out to find the y value of your vertex. We have negative and then negative 1 squared is a positive 1. Negative 2 times negative 1 is positive 2 minus 1. So this is really negative 1. So negative 1 plus 2 minus 1 makes a y value of 0. So yes, it says y less than 0, but remember, we're only worrying about the boundary right now. So my vertex is at negative 1, 0. So we're going to plot that coordinate here. Now, we need 2 more points to make an actual parabola boundary. So that's step 2. So step 2 is to find another point. Now, you can choose any x value you want. That's why they're independent variables. So we're going to choose, I'm going to pick an easy x to work with. I'm going to say x is 1. It's far enough away from the vertex that I'll get a pretty good picture, but it's also not an x value way to the right or way to the left that may result in a y value that's off my grid. So I'm going to choose x is 1, and I'm going to substitute that into the inequality. So y less than negative of 1 squared minus 2 times 1 minus 1. So we have y less than, well, 1 squared is a 1. Negative 2 times 1 makes negative 2 minus 1. So negative times a 1 is a negative 1. So negative 1 minus 2 minus 1 makes a y value of negative 4. So the coordinate that I have chosen is positive 1, negative 4. So I'm going to plot that. To find the final third coordinate, we're going to use that axis of symmetry to find the third point. We don't have to do math again. We can use the fact that I know that a parabola is symmetrical to this axis of symmetry here. So if this red point is, let's see, 1, 2 units away from the axis of symmetry, then that means another coordinate must be also 2 units away from the axis of symmetry. So these 3 points give me the basic idea of my parabola. The next step, the third step, is actually drawing in the correct version of your parabola. So we have to decide, is it a solid one or a dashed one? So that's going to be the inequality symbol from the top. So we have a y less than negative x squared minus 2x minus 1. So since this is a less than, that will result in a dashed boundary line. So that'll be a dashed parabola. So on my graph, we're going to draw in a dashed parabola through these 3 points. And the last piece to any inequality is a shaded area. So that's my step 4. Find your shaded area. So the simplest way to do this is picking a coordinate to test. So pick a coordinate either clearly on the outside of your parabola or clearly on the inside. It doesn't matter. I like to try to use 0, 0. So as long as the origin 0, 0 is not on the boundary line, you can always use 0, 0 to test. So we're going to test and see if 0, 0 is a solution. If 0, 0 is a solution, that means we're going to shade where the point is located. If 0, 0 is false, that means we're going to shade where 0, 0 is not located. So we're going to substitute 0, 0 into our quadratic inequality. So remember, x is 0 and so is y. So we have 0 less than negative of 0 squared minus 2 times 0 minus 1. And we're going to simplify this and see if we get something that is true or false. Well, negative of 0 squared is just 0. Negative 2 times 0 is 0. So we have 0 less than negative 1. Well, that is a false statement. 0 is not less than negative 1. So what that means is we want to shade without the coordinate point 0, 0. So since 0, 0 is here on the outside of my parabola, that means my solutions are actually inside because 0, 0 was a false statement. And here's the graph of number 1. So your basic steps are plot the parabola itself with step 1 and 2, decide what kind of parabola to draw, and then find your shaded area. For number 2, I'm going to help you start it, and then I'm going to let you finish it on your own. So the first step is finding the 3 points on my parabola. So the first thing we're going to find is we're going to find the vertex. Now, this one is actually in vertex form, which means finding your vertex is now a lot simpler. We can simply use h comma k to find the vertex. So -3 is the h, -1 is the k. However, remember that h is always the opposite. So since it shows a negative, my vertex is actually a +3, comma, a -1 for k. So the vertex in this one was actually a lot simpler to find than it was in example number 1. So pause the video, see if you can finish off graphing example number 2. And here should have been your solution for example number 2. So we found the vertex, we found another coordinate, and if you chose a different x, you will have a different point than I do. But you should still have the same basic parabola. The solid parabola should be solid because it is a greater than or equal to. That is what makes it solid. And then to figure out the shade, choose a test coordinate. I again chose 0, 0 because that's the easiest point to choose, and it came out to be true. So we wanted to shade with 0, 0 instead of without. Now, for 3 and 4, testing a point to be a solution. So for number 3, is the coordinate point 1, 2 a solution to the quadratic inequality? This has not changed since algebra 1. We're going to still take this coordinate and substitute and see if we get true or false. True things are solutions, false things are not. So let's plug in this point. So 2 greater than or equal to 1 squared minus 3 times 1 plus 1. And we're going to simplify to see if this is true or false. 2 greater than or equal to 1 squared is 1. -3 times 1 makes -3 plus 1. Well, -1 minus 3 plus 1 makes a -1, and 2 is in fact greater than -1. So that means that yes, the coordinate 1, 2 is a solution to this inequality. If you get something that is false, it is not a solution. Pause the video, try example number 4. And here's what you should have had for example number 4. Let's look at solving these algebraically. So for example 4, 5, and 6, we have single variable quadratic inequalities because we're actually going to algebraically figure out what value of x will make this inequality true. So the process is the same as linear inequalities back in algebra 1, except for the fact that you're solving a quadratic versus solving a line. So the first thing we're going to do is we're actually going to kind of ignore the fact that this has a greater than. We're going to solve it just by using equals because we first need to find the boundary points of this inequality. Just like with these two variables, we found the boundary of the parabola first, and then we worried about the shading. So same thing here. We're going to find the boundary on this number line. I'll go ahead and draw the number line here because we're going to use it. We're trying to find the boundary points first, and then we'll worry about whether or not to shade left, right, or in the center, whatever it needs to be. So solving this quadratic equation, we need to move the 2 over. So we're going to have 2x squared plus 3x minus 2 equaling 0. So with solving these, you have two choices, either solve by factoring or solve with the quadratic formula. So I'm going to try factoring first. So I'm going to multiply a and c together. So a is a 2, c is a -2. So -4x squared. And I need two numbers that add up to be b, which in this case is 3x. And I know that if I take a -1x times a 4x and I add those up, I do in fact get a 3x. So this is solvable by factoring. You could use the quadratic formula if you prefer the quadratic formula versus factoring. It doesn't matter how you solve these quadratic equations. So break apart b into -1x and 4x. Now look for common factors on the first two. So I can take an x out of the first two terms and I get 2x minus 1 left over. I can take out a 2 out of the second set of terms and I get 2x minus 1 left over. And then we look at what's common. These two factors are both common, and the outside numbers make the other factor. So to finish solving this, we need to split this apart. So 2x minus 1 equals 0, and x plus 2 equals 0. So my two solutions here, we're going to solve these small linear equations. So one boundary is 1/2, and the other boundary is -2. So I'm going to go ahead and plot those on my number line. Here are my two boundary points. Now let's worry about the inequality itself. So we've actually found the boundary. Now we need to figure out shading and boundary type. So because this is a greater than, that means it has to be open circles. So that means -2 is going to have an open circle, and so is 1/2. The final thing we need to find is shading. That's where another test point comes in. The easiest number to test is x equals 0. And in this case, 0 is not one of the boundary points, so I can use x equals 0 to test. So we're going to test x equals 0. So we're going to substitute this in and see if we get something that is true or false. So 2 times 0 squared plus 3 times 0 greater than 2. Well, 2 times 0 squared is just 0. 3 times 0 is 0. So I have 0 greater than 2, which in this case is false. So since 0 is not greater than 2, 0 is not included in the solution. So that means my shading actually has to be outward, not inside the boundary. So in this case, the shading is outside of the boundary because 0 was not a solution. So writing your answer algebraically, well, there's two pieces to this. We need this piece here, and we need this piece here. So for the yellow piece, we're going to have all the x's that are less than -2, because that's what this shading is. All the x's that are smaller than the boundary of -2. Or I need the right side. We want all of the x's that are greater than the boundary of 1/2. That's this way. So your final solution is two separate inequalities. Since the shadings did not overlap, you cannot write them as a single inequality. So pause the video, try to solve example number 5. Get the boundary points here either by factoring or by the quadratic formula, then unpause the video and we will work through the inequality part together. And here's what you should have had for your two boundary numbered solutions. So this one was in fact solvable by factoring, but even if you solved it with the quadratic formula, you should still end up with a boundary point of -1 and +4. So let's go ahead and graph this on our number line. So -1 is over here, 4 is on the right, and 0 is somewhere in the middle. So since this is a less than or equal to, that means we're going to have solid boundary points on our -1 and our 4. The last thing we need to determine is where to shade, and so that involves a test point. And so again, if you can, pick 0. 0 is one of the easiest numbers to substitute. So we have 0 squared minus 3 times 0 minus 4 less than or equal to 0. Well, 0 squared is 0. 3 times 0 makes 0. So we have -4 less than or equal to 0, which in this case is true. So that means we're going to shade with 0. Since we had a true statement, 0 is a solution, so we're going to shade wherever 0 landed, which in this case was in the center. Now, to write the answer for this one, since the shade is in the middle, we don't write two separate inequalities. We write this as a single inequality with a starting point and an ending point. So the smallest value is -1, less than or equal to because of the solid point. X is all of that orange shading in the middle. And then the highest number that you can have is a 4. So we use less thans only because we're writing it from least to greatest. So -1 is less than or equal to x, but is also less than or equal to 4. So for example 6, we're going to have to use the quadratic formula for number 6, and I'll show you why here momentarily. So again, we're going to solve this algebraically, which means we're going to ignore the fact that it has a less than. We're going to use an equal sign. Now, quadratic formula or factoring, we want to make sure our a value is a 1 because it makes life a lot easier with an a value of 1, or a positive, not a 1. With quadratic formula or factoring, we need to make sure that our a value is positive because having positive a values make factoring and the formula much simpler to use. So we're going to divide out -1 in order to change my a value to be positive. Now that we're here, if we tried to factor, we would have to do a times c, so we would have -3x squared, and we have to add up to be b, which in this case is 4x. Well, the way to make negative 3 is a negative 1x times a 3x. But when you add those together, you get a 2x, which is not what I need. It's not the 4. So then we try again. Well, the only other way I can do this is with a positive 1 and a negative 3. And if I add these up, I still don't get a positive 4x. I get negative 2x. So this guy does not factor. You cannot solve this one with factoring. And so instead, we're going to have to use the quadratic formula. So I want you to pause the video. Here's your quadratic formula. Substitute in your values for the quadratic formula and solve this. Find the boundary points with the quadratic formula. Pause the video and get the boundary points. And here's what you should have had for your boundary points. Negative 2 plus square root of 7 over 3 and negative 2 minus square root of 7 over 3. So let's think about where this lies on a number line. So the orange one will be overall a positive number. Square root of 7 is about 2 point something. And so if I do a negative 2 plus, let's say, 2.5, you're still going to end up with a positive value here. The red one, negative 2 minus square root of 7, if I take a negative and subtract another number, I'm still negative. So the orange one's a positive decimal, and the red one is a negative decimal. And so when you put these on your number line, make sure you put them in the right spaces. Negative 2 is going to be on the left, and then the positive version is going to be on the right, and we know that 0 lies between all negative and positive numbers. The shading area is what makes this guy an inequality. So first, we know the boundary points are going to be open because it's just a less than, and now we need to figure out shading. So again, we're still going to test some number, and 0 is still not a boundary number. So we're going to test x equals 0 and see what happens. So we get negative 3 times 0 squared minus 4 times 0 plus 1 less than 0. And we're going to see if this is true or false. Negative 3 times 0 squared is 0. Negative 4 times 0 is 0. So we have 1 less than 0, which is not true. So that means our solutions are actually outside the boundary points. They are not inside. So since the shading is outside the boundary points, we have to write two separate inequalities. So we're going to write one inequality for the red shading and one inequality for the orange shading. So for the red, since it's shaded to the left of that boundary, it's x's that are less than negative 2 minus square root of 7 over 3. Or, and for the orange one, because the shading is to the right, it is x greater than the boundary point of negative 2 plus square root of 7 over 3. So just because we had square roots left over in our answer, the process itself didn't change. We simply had to find the boundary points and then decide where to shade. And based on that was how we wrote our answer, as one large inequality or two smaller individual ones.